Hi everyone, welcome to my YouTube channel Erudispace. I am Dr. Mohanty, and today we'll discuss about the gas turbine cycle with intercooling and regeneration. While discussing the use of intercooler, reheater and regenerator, I have explained in detail what are the advantages of providing these components, and today we will consider a gas turbine cycle which is using both the intercooler as well as the regenerator. All of us know that the intercooler helps in improving the work output of the cycle by reducing the compression work. Similarly, the regenerator actually helps in some waste heat recovery, thereby improving the efficiency of the system. So let me draw the schematic diagram of the cycle. So first you do have the first stage compression. After that it is taken to the intercooler, and after that is taken to the second stage of the compression, and after that it is taken to the regenerator, and then it is taken to the combustion chamber, and after that it is taken to the turbine. Both the compressors get drive from the turbine, then the products of combustion leaves. So this is the first stage compression. This is the second stage compression. This one is your intercooler. This one is your regenerator. This one is your combustion chamber. And here heat and fuel are added. Air is actually taken in, and you have the adjust gases. This is 0.1, this is 0.2, this is 0.3, this is 0.4, this is 0.5, this is 0.6, this is 0.7, and finally it's 0.8. So first of all, air is taken in and it is compressed to an intermediate pressure in the compression. Then it is taken to the intercooler. In the intercooler it is cooled, its temperature is significantly reduced, and then it is taken to the second stage compression, where it is compressed to a higher pressure. After that the air is made to pass through the regenerator, where it receives heat from the exhaust gases, thereby some portion of the waste heat is utilized. After that it enters the combustion chamber, where heat and fuel are added and huge amount of thermal and pressure energy is developed. Then the gas is taken to the turbine, where it undergoes expansion. Here we get power output, and then the exhaust gas is made to flow through the regenerator, where it transfers heat to the air that is coming from the second stage compressor and entering the combustion chamber. Let me draw the PV and TS diagram to show the processes. First I will draw the PV and then the TS diagram. You do have the first stage of compression followed by intercooling. Similarly, we do have the TS diagram. One, two, then you have 3, then 4, then 5, 6, 7 and 8. So what we have discussed, that is also represented in terms of PV as well as TS diagram. First you will have isentropic compression that is taking place in the first stage of the compression. Then it is taken to the intercooler. In the intercooler it is cooled, and by providing the intercooler, this is the savings that we make in compression work, which actually helps in net gain of the work output, because unlike the turbine, the compressor is a power consuming device. So this is the saving that we make. While discussing the uses of intercooler, reheater and regenerator, I have explained in detail that how the savings in work output is obtained by providing the intercooler. You can refer to that lecture to have a better understanding about the gains in work output by providing the intercooler. Then it enters the second stage of the turbine where it is compressed, and after that it is taken to the regenerator. This is your regeneration process where it actually recovers some amount of waste heat, and after passing to the regenerator, it enters the combustion chamber where it receives heat and fuel, and this is represented by 5, 6, and then you have expansion taking place in the turbine. You get power due to this, and the turbine is also used to run the compressor. So the net work will be the power that is developed in the turbine minus the work that is consumed in both the stages of compression. After that, the exhaust is made to pass through the regenerator where actually it transfers it to the air that is leaving the compressor and entering the combustion chamber. And the flow of the exhaust gas is counterflow to the direction in which the air is coming from the compressor and entering the combustion chamber. I have also told you that the effectiveness is very, very important as far as the regenerator is concerned, and effectiveness is represented by eta. And effectiveness is actually the difference between the actual temperature rise to the maximum possible temperature rise, and in this case it is T5 minus T4 divided by T7 minus T4, because T5 minus T4 is the actual rise in temperature of the air, and T7 minus T4 is the maximum possible temperature rise that is possible. So what is T7? T7 is actually the temperature at which the exhaust gas is leaving the turbine and entering the regenerator, and effectiveness in all practical applications is less than 1. The next important thing that we are going to discuss is about the efficiency of the cycle, and all of us know that efficiency of any cycle, eta, is actually the ratio between the net work output divided by the heat supplied. Now, what is W net? Here we are having the work obtained in the turbine, and then you have the work that is consumed in both the stages of compression. First stage, you may represent it as WC1 plus WC2 represents the second stage. And as far as the heat supply is concerned, the heat supply is taking place from 5 to 6, not from 4 to 6, because this is something that is recovered. So, heat supplied is the enthalpy difference between 0.6 and 5. You may represent this as F6 minus H5, that is the heat that is supplied. Similarly, WT is the work that we obtained, that is F6 minus S7 minus, as far as the compressor work is concerned, that is H2 minus H1 when you are considering the first stage of the compression, and then you have H4 minus H3 when you consider H4 minus H3 divided by H6 minus H5. And in terms of temperature parameters, simply you have to substitute the H values by T values, because all of us know that H is equal to Cp into T. By providing the intercooler, we save the work that is consumed in the compression, and by providing the regenerator, we can improve the efficiency by supplying less amount of heat or by utilizing the waste heat. So I sincerely believe that today's lecture on gas turbine cycle with intercooler and regenerator would be extremely useful for all of you in understanding the concept of both intercooling and regenerating when both are there in open cycle gas turbine. If you have any doubt related to this, please do put questions so that I will try to answer. I must extend my sincere gratitude to all of you for watching this video and having the patience to watch the cell. If you have not subscribed to my channel till now, I would request you to subscribe to my channel, and I would further request you to share this video with your friends and relatives. Hope to see you soon for another lecture on my YouTube channel Erudispace. Thank you.